Hello friends, today I will discuss about plastic section modulus of a rectangular section. How to find out the plastic section modulus of a rectangular section. Now see here. It is a triangle whose base is B and total height is H, capital H, okay, and base is B. So first of all we have to know what is plastic section modulus. Plastic section modulus is nothing but it is the moment of area about the equal area axis, okay. So now first of all we have to find out the equal area axis, where this equal area axis situated in this triangle. So first of all we have to assume, suppose it is the equal area axis EAA. Now I will find here what is the value for, suppose this is small a, so what will be the value of the small a, and it is the small b, okay. Now we know that equal area axis means that axis which will divide the whole section into equal two areas, okay. That means the area of this triangle and area of the remaining part will be same, okay. Now area of the big triangle will be half into base b into h. This is a total area, so and its half area will be, that means divided by the 2, okay. That means 1/4 to b into h, okay. Now sorry, do capital H. Now the area of this small triangle will be, now area of small triangle equals to half into small b into height h, okay. Now this area and this area will be equal, okay. So area of this portion and the half area will be equal to, so we can write here half into b into h equals to 1/4 into capital B into capital H, okay. Now this 2, so it will, so from here we will get b equals to capital B into h by 2. It is number 1 equation. Now from geometry of this two triangle we can write here capital B by capital H equals to small b by small h. So here we can write here, or b equals to capital B into h by capital H. We can write here, this is the equation number 2. Now if we equate these two, so we will find the value will be b into h by h equals to b into h by 2. Okay. Now this b and this b get cancel out. So here h equals to h square by 2. Actually here we will mistake here, half into b into h, so it will be into 2h, sorry 2h will be here, so and 2h. okay, so from this it will be h square equals to capital square by 2, so h equals to will be h by root 2. And now if we put this value in this equation number 1 or equation number 2, we will get small b equals to capital B by root 2. okay, so small h equals to h capital H by root 2 and small b equals to b by root 2. So now from here we can write here h equals to capital H by root 2 and b equals to capital B by root 2. okay, so now it is the capital B by root 2. So here this distance will also be capital B by root 2 and this distance will be, so actually so now this distance of this remaining portion will be how much? H minus h by root 2. okay, this distance will be h minus, total distance is h and this distance will be h minus h by root 2. okay, now this is now this area, this equal area axis divides the total area into 4 parts. This one is first part, one triangle, this is one rectangle, and this is one triangle, this is also another triangle. Now we know that the plastic section modulus is the area, moment of area about the neutral area axis. okay, now for the first case, here the area of the triangle will be half into b into h. So now we will find out the total. So here ZP plastic section modulus will be half into, first one we have to find out this area, half into b, that means here b is capital by root 2 into h is the nothing but is capital H by root 2. it is the area of the small triangle. Now here, so moment of area, that means the moment will act, it will be act, that is the h by root, that is the from 1/3 of this height from this okay, 1/3, that means it will be h by root 2 into 1/3. okay, so we will multiply here h by root 2 into 1/3. so it is for the first triangular section, upper triangular section. Now in this case of this rectangular section, so here the area is given by this plus area equals to b, that means the base is nothing but b by root 2 into, so here it is the b by root 2, this distance is b by root 2 and this distance is h minus h by root 2, h minus this distance is h minus h by root 2. so we can write here b by root 2 into h minus h by root 2. This is the area of the rectangular section and it will act, that means moment we will take, this is the half of the section, that means h minus h by root 2 by 2. Okay, so h minus h by root 2 by 2. Okay, okay, now it is for triangular portion, it is for the rectangular portion. Now two rectangle also is there, two triangle is also there, also here, this triangle for this triangle. So for this triangle actually total length is b, so this length will be how much? This length, this length of this portion will be b minus b by root 2 divided by 2, because b minus b by root 2 will be this for this two portion. For so now for its individual portion this length will be b minus b by root 2 by 2. So area of this triangle will be half into base this mass into height, that means h minus h by root 2. Okay, so and here it is the actually, so we have to multiply this by 2 because it will be because this two triangle is similar and area of this two triangle will be same, and this will act from the two third from I mean two-third from the neutral area axis. Okay, from this two-third, that means h minus h by root 3 into 2 by 3. Okay, so now for the next two triangle, area will be half into base will be b minus b by root 2 by 2 into height will be h minus h by root 2 into this I mean this length will be two-third, so two-third into h minus h by root 2. Okay, now into h minus h by root 2 into two-third. Now it is for one triangle. Now here is two triangle, this one and this one, so we have to multiply this by 2. Okay, 2. So this is the complete calculation for the section modulus or rectangular section. Okay, thank you guys.